Okay, so this is my long title of my talk. Symfony loves Kubernetes dynamic feature review environments. I want to spend a single minute explaining what I mean. Obviously, this is a talk about Kubernetes, and I will try to give you an overview of the technology and give you enough information as developers to understand if this technology is right for you and for your project. So I will skip over stuff that should be a concern for DevOps system people and stuff like that. But the subtitle, the dynamic feature review environment, what I mean by that? I mean that I want to give you the possibility to deploy a single branch of your project with a click. So spin up an ephemeral environment where you can test what you're building. You can give it to, I don't know, QA people, product people, managers, clients. So you can show them what you're building, what you're writing while you're doing it, not at the end of it. And I think this is the most powerful thing that you can do with Kubernetes. So obviously the presentation about myself is redundant since Daniel already did it for me. I work at Facile, right? I organize the user group in Milan. I am a part of the PHP Fig. If you want to talk with me about all of these three things or all about the talk, just stop me around the conference, ask me questions, don't be shy. So let's dive right to the arguments, to what we need to see here. So PHP and Symfony in this conference and Kubernetes. I already talked about this in other conferences, and I always said that I think that Kubernetes is really a good thing that is happening to PHP because it gives us finally what we were missing comparing to other languages like Java. So we have a possibility now to deploy our application like an artifact, like something that is built in a single piece, and then it contains everything. So no more zips with all PHP files and nothing else, but we have containers, Docker images, and that means that with a single blob, with a single artifact, we are deploying both the engine, so the PHP version, the extension, and everything else, and our code. So we can be sure that we have both the right environment and our application. And that is not true if you're just spinning around the PHP files. You have to be sure that your server is up to date with the right version, with the right extension, the right configuration, and so on. Instead, Kubernetes gives us the possibility to deploy everything in one step. So first, a bit of history. For those of you who doesn't know, Kubernetes is an open source project written in Go, and it takes inspiration from Project Borg, which is the project that Google uses for a decade, if not more, to deploy over the world with containers. So they knew what they were doing. They donated this open source project as a seed technology. So they started what is now the standard de facto way to deploy with containers for us. And if you want to know everything else, I just linked a bit of history in here. All the slides are filled with links, especially at the end. Slides will be linked in my social account, and joined in, and everywhere else if you need them. So the basic structure of a cluster with Kubernetes is this one. So you have a master node, like in a cluster for, I don't know, a database like MySQL. And this master node has etcd, which is a daemon to hold configuration, an API server, a scheduler, and a controller manager. The scheduler is something that decides what needs to be run on the cluster. And the controller manager is the piece that decides, okay, this piece of code needs to be run. Okay, I need to run it somewhere in these worker nodes. The worker nodes are instead the workforce of your cluster. So are other nodes where you can basically spin up containers and make your application run. On the worker nodes, you will find a kubelet, which is basically the other side of the controller manager. So it's the piece that the brain of the cluster uses to command the workers. Kubeproxy, which is just a network manager. So inside the cluster, there's a private network, a virtual LAN, where everything lives, basically. And a container runtime, so you can think the Docker daemon. Docker is not the only daemon that you can use, but it's the most common, obviously. How many of you use Docker at least on development? Raise your hands. Okay, a lot of people. So you know what I'm talking about. You don't need to know the inner workings of Docker. Basically, everything that that you use normally on your workflow is the same that is used on the worker nodes. As for cluster, you can have a very tiny cluster with one single node. If you, for example, try to use Minikube, which is a simple tool that lets you spin a Kubernetes cluster on your PC. It's just a VM where a single node acts both as master and worker. And on the other hand, if you want a production grade cluster, you obviously will need a public vendor cluster like Google or AWS. Or if you want to build one yourself, you will need at least three master nodes for high availability, and as many workers as you want. So it depends on how much workload do you have to deploy. If you want to talk to a cluster, you normally use kubectl, which is a tool from the command line. So here we start to see some stuff from the console. I'll try to zoom a little. Oh, too much. Okay. When you use kubectl, you have to use autocomplete because it's really a must, but you can basically ask him whatever on your cluster. So you say get in the same way that you use get with an API REST, and then the type of resource that you want to know. So in this case, I want to know which nodes I have on my cluster. Let's see if it works. Okay, I have a simple demo cluster with one single worker node. This is the name, it's on Google Cloud, it's ready, this is the version, and that's all. You can play a lot with this because if you use safe verbs, like still in REST APIs, you can just read what your cluster has. So you can have, for example, the scribe to see the detail of the node. You will probably print a lot of stuff, how many things are running on there, how much resources are consuming, and so on. But this is not so important for my talk. Okay, so this is the basic structure. And the point is, it's actually an API. The master node actually has a REST API. You will not talk to the API directly. You will not use Postman or stuff like that. You will use normally kubectl, but the concept is there, so it should be familiar to you. It even exposes resources in the same way as an API REST exposes this kind of stuff. So it's an API for the cloud, we can say that. So you can handle your worker, your servers without thinking about the installation, the operating system, and stuff like that. You don't need to think about it. If you use a public vendor, you just say, okay, I want master, and you don't even have to install the master because it's even free. You don't even pay for that. You pay just for the worker nodes and the resources, and it will just spin up a virtual machine for you. How many do you want, and with how much CPU and memory do you want? You don't have to care about the Linux distribution or drivers or stuff like that. It's not up to you. They just say, okay, you have a worker node with 2 CPU, 4 GB of RAM, and Kubernetes 1.13. Okay, that's all. When you have to work with the cluster and you are a developer, you have just to know which resources you will be using. And the first resource that you'll be using is a pod. The pod is the minimum scalable unit inside Kubernetes. So basically, it's the building block of your application. A pod is comprised of one or more containers, and a container inside the pod can talk to the other one on the localhost. So the base case for you will be a pod with Nginx and PHP FPM. You will expose port 80 for Nginx to the exterior world, and then Nginx will talk to PHP FPM on the port 9000 as always. And that's all. The strange thing here is that you will never create a pod by hand. This is something that Kubernetes juggles for you. You will not say, okay, I want to create this, so I launch a kubectl create pod. No. Normally, you do that indirectly with other resources. The main one is the deployment. The deployment is basically a blueprint of a pod. So you say, okay, I want a pod of this kind, with these resources, with these containers, this port, this configuration, blah, blah. And I want 2 of them, 3 of them, 4 of them. And Kubernetes will take care of spinning up 3, 4, 5, 10 pods, as many as you want. And this is nice because it means that you're describing your desired situation, and Kubernetes will strive to reach the desired situation every time. It's like a state machine. So you describe the desired state, the transition is up to Kubernetes. For example, if you have 10 pods and one of the nodes crashes, dies, it will say, okay, now I'm down to 8, I have to spin up 2 more somewhere else. And you don't have to do anything. Kubernetes will do that for you. It will always strive to reach what you're asking him to do. The other thing that you need to know about deployment is that you have 2 additional resources, which are config maps and secrets. Those are, you can think of them like key value stores. And the only difference is that the secrets are not in plain text. So you can hold configuration, API keys, values, anything you want in there, even full files, TLS certificates, this kind of stuff. So basically, you put this stuff on the cluster, and you describe into Kubernetes what the values of your configuration are. And you can inject them through the deployment inside the pods. The other way to create pods is a job. And the only difference between a deployment and a job is that the deployment never ends. It's like a daemon. So if you want to spin up a web server, you use deployment. If you want to do, I don't know, a Docker migration, a batch elaboration of your data, you use a job. The job is a process that starts, and Kubernetes waits for its ending with an exit code of 0. Otherwise, it retries. But if it exits with 0, it's fine. It's done. It's completed. So the job will basically, it's the substitute for SSHing into the server. Since you will no longer have a server, you just have containers, this is the way that you will use to execute job manually. Well, not exactly manually, because once it's started, it goes without you having to look at it or having to have your SSH connection stable, no hop and stuff like that maybe sometimes you do on your servers. The next step, it's obviously the cron job. You can leverage a job to have the same stuff of a cron tab on a server. So it's just a resource that say, okay, in a particular point of time, I want to spin up a job and do something. It even has the same syntax of a cron tab, so it's pretty familiar to you, I hope. Okay, and these are the building blocks to build an application. Now we have to expose it to the exterior world. The first step that you need is a service. And you can think of the service like a load balancer. You have your pods, but you don't know how to reach them and how many of them you have on a precise moment. So the service is just a placeholder with a name that is resolved by the internal DNS of the network. And you can basically talk to the service and ignore how many pods you have. If you have, I don't know, maybe you are having a deployment in the same time, so you have a rollover of pods, you don't have to care. You have a single name with as many ports as you want to connect to, and it will just balance the traffic to the correspondent pods. The last piece that you need is the Ingress, which is the door of the cluster to the exterior world. You can think of it like a reverse proxy. So basically, you can stuff on the cluster as much application you want. You're not constrained to have a single application, obviously, on a cluster. And it just redirects the traffic depending on the host header of your HTTP requests. And that's all. Obviously, there are a lot more resources in there, but as a developer, you don't have to handle them. You can even describe custom resources, and you can install them in your cluster, but still, this is something that you should not bother about. It's something for a DevOps or system people or stuff like that. Now, I want to give you a practical example of what these resources are. In the slide, I've put YAML. Okay, there will be a lot of YAML. Sorry, I'm making some Marco cry somewhere in Germany. I know. But this is the way that it's used in Kubernetes. The nice thing is that if you use this YAML with kubectl and apply to your cluster, it will be validated because there's an API description behind, so you can be sure that it's really hard to screw up. If you want, you can even use JSON, but it's a little harder to edit by hand, so that's why I'm not using it. I have a repository with the code that I will be using. Wait, I want to demo. Okay. It's linked to in the slides, in joined in, and so on. Let me zoom in for you. Appearance, presentation mode. Okay. You can see that. I need to switch to white. No? It's readable? Okay. Okay, I have a Kubernetes folder in here. Where basically I have all the YAMLs that builds up my demo application, which is obviously a Symfony 4 application. I will try to do the opposite route in here. So start from the Ingress and go inside. So the Ingress is probably the most simple resource that you can have. Every resource in Kubernetes is written like this, so you have 3 dash as separators, so you can, for example, do something like that and have multiple resources in the same file, if you want, but it's not needed. Then you have an API version and a kind, Ingress. Okay, this is the kind of resources that we're talking about. If you see stuff like deprecations or autocomplete, it's because I'm using a PHP Storm plugin for Kubernetes. Also, each resource has a metadata key and a name. The name is basically the ID of the resource, so you cannot have 2 resources with the same name. But don't worry, the cluster has namespaces, so you can split the cluster as many times as you want. At my job, for example, we use 1 namespace for each project, so we are using the same cluster between 7, 8 teams without issues. Then you can have labels that are optionals, key value as free as you want. You can write anything that you prefer, and annotation that are used to drive some behaviors. This is, for example, the way that I used to say, okay, I want an Ingress that as a backend uses Nginx. This is useful later. I will show you why. Then you have the heart of the resource, which is the spec. And in this case, for an Ingress, you have just rules. So you're saying, okay, I want a reverse proxy that behaves like that. So I have this domain, everything that has this host in the headers, I will need to redirect them to this service. So this name and this port. I've also added this piece, which is commented out, because I use that in production, but I don't have a TLS certificate for the demo. The point is, you can store TLS certificates at the cluster level, and your application doesn't have to know about it. It's really nice as a thing, because you can have, for example, the certificate for all your application. For example, at my job, we have third levels domains, and we have a single TLS certificate. So the Ingress is basically doing TLS termination and handling that for you. The traffic inside the cluster is in clear text, but you don't have to worry. It's a private network. It's not open to the public. The Ingress is the only point in. Then the next step, going up to the diagram that I showed you before, is the service. It's pretty simple, this one too. So API version, kind service, name, labels as free as I want. And then you have, for the spec, for the service, a type. You can have 3 kind of types in the service. You have node port, cluster IP, and in some cases, load balancer. The load balancer is available when you are on a public cloud like Google or AWS. It just spins up an effective load balancer for you, so a public IP that routes the traffic. The difference between node port and cluster IP instead is, with cluster IP, you're just creating a placeholder, which is resolved by the DNS inside the cluster, and that's all. The node port instead will expose a random A port, like 3000 something, to every node of the cluster. It's not used normally to route traffic in a production application, but sometimes it's useful. I don't know, if you have a staging application and you want to expose, I don't know, the database or stuff like that, because you want to access it easily without any issues. Apart from that, you have to specify which port you are exposing. You can give as many ports as you want and give them names too if you want. And then this is the important part, the selector. Basically, I'm saying which labels will match the pods that will receive the traffic. So this is the first case where labels matter, basically. Next step down in the rabbit hole, the deployment, which is the only one which is a bit verbose, but it's still simple because you have still API version, kind, metadata with name, and then the spec. The spec has two important pieces. The first one, it have a selector like the service, but it's not so important. You just have to copy paste it if you want. But this is the core of the power of Kubernetes for you as developers. Basically, if you are able to describe your application with a deployment, you're done. Because it will handle for you the deployment, the rolling deployment, the substitution of pods, and so on. So you don't have to use stuff like Capistrano, Capifony, change of links, of symlinks on the servers, blue-green deployment. You don't have to worry about that anymore. Because you just say, okay, I want 2 pods. I want to use the rolling update strategy for the deployment. And these are the parameters. So the rolling update means that when you say, okay, I'm changing my desired state, I want to update my image, that's all. And Kubernetes will take care of rolling out the pods gradually, one by one. The parameters under the rolling update key are just to say how fast do you want that to happen. So both can be expressed as integer or percentages. And the meaning is max surge, how many pods I want to schedule on top of the one I've requested. So if 2, 1, that means that I can spin a new pod on top of the 2 that are rolling in this case. And max unavailable is the opposite. How many I can shut down before saying, okay, this is enough, I cannot shut down anymore, or my application will no longer be available. So with 50% is the same. I'm saying, okay, you can go 1 up and 1 down. So what happens is that when you ask for a deployment, Kubernetes will start with creating a new pod with a new image, will shut down one of the old one, place the new one in the same under the load balancer, under the service to get traffic, and then you spin up a new one and replace with the old one, and that's all. Obviously, we just do the example. It's pretty simple. You can have 10, 20. You don't have to care. It's the same. You just have to decide how fast you want that. The only drawback to use higher values is obviously that you will consume more resources. So you're constrained by how much money you want to spend on your servers. Then on the template, you will be describing the pod. It's, as I said before, a blueprint. So like a cookie stamp, okay, for the pod. You have to describe, okay, the labels of the pod, and then what it's inside the pod. So this is the first time that we are trying to describe a pod. You have to say, okay, I will use a secret to log into my Docker registry, because probably your images will not be public. So you will have to give access to Kubernetes to your registry. And then just a list of containers. Each container has obviously an image. You can say if you want to pull them every time. You can give them a name, and then you have to describe how much resources will be using and if they expose ports to the exterior world. So this is obviously Nginx, has port 80 exposed to the exterior world, and uses these resources. For the resources, we have obviously memory and CPU, and we have requests and limits. What's the difference? The request is basically an estimate. So you're saying to the cluster, how much do you expect to use normally? On average. It's used to spread the workload evenly on all the nodes. So he knows, okay, I can expect not so much CPU usage and 16 megabytes of RAM from Nginx. Okay, that's normal. it doesn't even consume enough to notice, basically. The limits instead is how much it can consume even on a spike. So if it uses too much CPU, it will be throttled, so it will go slower. Instead, if it uses too much memory, it's harsh, because due to Linux kernel limitation, you cannot partition the memory. You cannot separate that, you cannot throttle that. So if your application starts using too much memory, it will be killed by the kernel, which is bad. So normally you tend to put high limits and just use the real average request to be sure that your cluster behaves correctly. Then it may depends if you want to overbook your resources or not, but this is the same issue as before. The only constraint is basically money, how much money you want to spend on your machines. In here we have also obviously a PHP container, which PHP FPM. It's the same, basically, it has the same values. Obviously, I'm allocating a lot more resources in there because that's the firepower of your application. But I also added an example for the env key down here. In here, basically, this is an example of how you can use config values and config max, and secrets to inject configuration in your application. You normally use environment variables. And in here, you probably have a click in your brain because now you start thinking, that's why Symfony 4 started using environment variables and .env component and stuff like that. They didn't invent that. This comes from something which is called the 12 factor. It's a manifesto that Heroku wrote, I think, nearly 10 years ago. Heroku was basically the first real cloud provider, and they tried to describe with that manifesto how you should write your application to be cloud ready. And this kind of stuff really kicks in when you want to work on Kubernetes, because in this way you can basically have a single image for your production application, and just by changing the environment variables, the secrets, the config maps, you change your application. In the meaning that you can deploy it multiple times. You can use the same image to have, I don't know, staging and production and stuff like that, without changing a single line of code with the same commit. And this is really powerful because you're really reducing the distance between your environments and the possibility that you're creating a bug just because you have a configuration difference between staging and production, which is really nice. It's easier to debug. It's easier to narrow the scope when you want to debug a bug and you cannot find the source of it and stuff like that. I've also added a Cron Job example, but it's basically identical to the deployment because the only difference is that instead of the deployment parameter, it has parameters for the cron job. So same syntax as cron tab, familiar to you, I hope. Suspend, it's basically a on-off switch for the cron job. And how many pods you want to store after completion so you can inspect the logs and stuff like that. Then afterward, it's the same. You have a spec where you have a description of the pod that you need to spin up. And the only great difference is here. You can override the command as you can do with Docker Compose, with Docker Run and stuff like that. Because obviously, what happens with the Symfony application in here is that you will reuse the same PHP container as the web application. You just say, OK, I don't want to spin up PHP FPM. I want to do bin console something. OK. I think that for now we can go back to the slides. I hope that I don't have said something too complicated. If someone has a question, just raise your hand and stop me because this talk is a bit dense, so I hope that I'm not skipping over some basic stuff. This is a screenshot that I used last year, still here at Symfony Day, because I did a talk about how to put your Symfony application inside Docker in production. And I've stopped shy of showing how much I'm showing you in here today. So if you understand Italian, I will suggest you to see the video of last year's talk, because it will fill in some gaps about how I handle Docker and Docker Compose in my pipeline and something like that. This is a screenshot of my pipeline on GitHub CI of one of my projects. And that's basically it. This is what I want to do on production. So I have a stage with tests PHP stan and code style and stuff like that. Then I build my images for the production, and then I deploy. Then I do some stuff after the deploy, but it's the same that you do manually. So I say New Relic, oh, hey, I've deployed. I clean up some stuff, and that's all. But the nice thing that I showed last year is that the deploy production job is just 2 lines of code, 2 commands. And this is it. So I use directly kubectl. I say, okay, I want to change the image for this deployment with that value. And then I want to watch the rollout. I want to see if Kubernetes is rolling out the pods correctly. This command, the kubectl rollout, is really nice. It's basically for the CI, for the pipeline, because it just stays here, outputs something like that every few seconds, and if something goes wrong, it exits with something different at 0, so your pipeline fails. And this is how I've started deploying on Kubernetes, I think 1.5 years ago, something like that. And it's nice, it's simple, but has limitations. Normally, the limitation that you will incur is, okay, with that, I can change my image, so I can change my code and deploy it in the same way that I do with a VM, with AWS and EC2 and stuff like that. But what happens when I want my application to evolve? What happens when I want to add something new, some new pieces, some new command, a background process, a batch process, a queue with consumers and stuff like that? So what happens when I need to change the YAMLs, the resources that Kubernetes builds up for me? And here enters Helm. Helm is another open source project which is built inside the Cloud Native Computing Foundation, or CNCF for short. The CNCF is a foundation like the Linux Foundation that basically oversees all the Kubernetes ecosystem. So every open source project which is around Kubernetes is handled by them, basically. And Helm is 3 things. It's a templating engine, so you can think Twig, but for the YAML that I've shown you before. It's a package manager, so it allows you to basically write charts, which is a package for your application, so you can wrap up all these YAML in a single package. And then it's a deployer. So it's a more dynamic way to deploy on Kubernetes without to do it manually. kubectl, set image, kubectl, apply -f from this YAML file and stuff like that. And this is how I'm deploying to Kubernetes right now at my job. So from here on, it's basically live demo. I'll try to show you how I do it. So as I said before, raise your hand, ask question if I'm skipping over something. Still on the project, I have another folder which is charts, obviously. And that's the trick of this application. The trick is I didn't wrote everything in here, this YAML. I didn't do it. I've used Helm to do it. So basically, in here, we have the structure of a YAML chart. So you have a chart YAML. Yeah, I know, still YAML, but that's the harsh reality, which is really, really short, just a name and a version. If you're building a chart for your application, you don't even have to worry about the version because you're not redistributing it outside. So it's the same as your composer JSON when you don't write a version, because you're just deploying dev master each time. And then you have a values YAML, and you can think of parameters YAML from Symfony 3, stuff like that. So in here you can save all the parameters that you will be using in the templating. As PHP developers, we probably are familiar with templating. Okay, so you can easily imagine how powerful is having a templating engine to write YAMLs, because every boring stuff that you have on that YAML, so repeating structures, parameterization, stuff like that, you can do the same as you do with Twig. So you can have partial, you can have variables, loops, conditional, and stuff like that. The only downside here is that it's not PHP, and Unfortunately, they use the Go templating engine because everything in the Kubernetes ecosystem is written in Go, so I'm sorry. But it's still pretty readable. So this, for example, is the template for the Ingress resource that I'm showing you. So kind of similar to Twig, the double brackets. And you can have assignments, you can have an include, so you can say, okay, I have a partial somewhere else that has the same pace. So for example, every time that I wrote the labels, I'm just copy pasting it with a partial. Okay, I have a single place in here where I say, okay, I want those values for the labels every time. So I'm sure that I'm not doing a mistake there and copy pasting the wrong value so the pods will not match and stuff like that. I have, for example, another partial in here for injecting the environment variables. So I'm sure that I'm getting always the same name from the same secret and the same key and stuff like that. So every time that you are repeating something, you can do something like that. But this should be familiar to you because PHP is born as a templating language. So it's what we do every day, basically. Obviously, doing stuff like that, it's a bit hard in YAML because you have to care about indentation and spaces and stuff like that. So you can see a filter like this one. So I'm saying, okay, that's the partial, but I want to have 4 spaces on the left. And since this is a bit hard, this is why if, for example, I do a mistake like this one, okay, I use the wrong value for indentation, I use this nice trick. I have a makefile and I do Helm template. Basically, I'm outputting locally the result of Helm. So I can see the result and I can inspect it and see if I have some issues. In this case, I can even use, let me see if I can, no, what's the shortcut for Git? No, let's see from Git diff, it's the same. I can even use Git to see if where my mistake is. What's the difference between what I've committed, because I'm committing the result of the Helm charts, what I've changed. So this is basically the test for my chart. I can see live what I'm changing. I can refactor the chart, being sure that I'm not changing anything. For example, I'm not adding a space by mistake, mangling something in the structure, changing a value. And so I can be sure that when I ask Helm to deploy the chart on my cluster, I'm not making any mistake. In my project, I've even added CI job near the tests that says, if the Helm result is different from what is committed, fail. So I'm sure that I'm not committing something broken on my deployment. In my demo, I've also used GitHub CI. This is basically the project that I'm using for this presentation, and has the same code that I'm showing you. And the nice thing, if you don't know GitLab, it has a continuous integration pipeline service inside, built in. And these are the stuff that I was doing this morning on the train. So the last pipeline that I ran. So when I push the master, I'm basically deploying to prod. Obviously, I don't have tests here to make it faster. But as I said before, building the 2 images, pushing to the registry. I have the registry on the project too. It's a service on GitHub CI too. And then deploying, okay? But the deploy is kind of simple. I have basically just the only 2 commands that I have are Helm init, that just initialize Helm, and Helm upgrade, which is basically the installation itself of the application, the deployment. Helm init is necessary because Helm has another component which is called tiller, which lives inside the cluster, and it's basically Helm's agent. It lives inside there and moves around stuff to do the actual deployment. This will not be true in the next version. This is Helm 2. Helm 3 is currently in beta and will no longer have tiller because security mistakes, issues, and stuff like that. Having two pieces that have to be synchronized is hard in computing, so everything will be done in the CI, basically. Helm stores everything inside the cluster too. So if I go kubectl get config maps, I didn't use config maps for my example, but I will have a lot of config maps here because Helm is using them. So I think it has maybe config map. Let's try sfday prod v, I don't know. Okay, this is autocomplete kicking in. Okay, a lot of basic 64 to store. You don't have to care what's written there. It's just a snapshot of what you're asking him to do. That's all. And this is nice because you can ask him for a rollback with Helm rollback, and that's all. Or, I don't know, maybe just redeploying the specific commit that you want. It's not an issue. Helm works with the same configuration of kubectl, so you don't even have to have a different configuration. If kubectl is talking to your cluster, will be the same for Helm. Now I just have to show you how I did it with GitHub CI. So we can go here. I'm sorry, still YAML, I know. GitHub CI. So this is basically the description of the pipeline. You have just to commit this file in your repository, and GitLab uses it to configure the CI. Most of the stuff that you can see here, it's stuff that I presented last year in the talk, but it's kind of simple. Basically, I'm just saying, okay, I want to run using Docker Compose. I want to log in inside my Docker registry to reach my images, but with GitHub CI, it's kind of simple because it will inject the login for you. And I use Docker Compose to store some of my configuration. And then I have my stages, so test, build, deploy, and stop. We'll see that later. I use these kind of labels with the dot at the start. Those are basically templates that I can reuse. And I'm just saying, okay, for prod, I want to run only on the master branch, and if the branch is called hotfix, which is kind of nice because I can try an hotfix and push it directly to prod without going to the CI and stuff like that. It's something that I use sometimes. And for staging, develop. So basically, every time that I push on master, production. Every time that I push on develop, staging. Okay? Probably some of you already do that, something like that, but not with Kubernetes. For the build, I've separated the file in here. I have a template for the build too, but it's kind of simple. Docker Compose pull to pull the base images and the cache, so the build is faster. Docker Compose build and Docker Compose push. Okay, you have to worry about obviously your Docker file, your image and stuff. Everything else in the project, there are the example for the Docker file. So I have a base image for PHP, which is obviously starting from the official file. And then I have a production image that starts from my base image and just adds everything on top. So I had composer, JSON, and lock. I install the vendor. I copy all the files of my Symfony application, taking care of the fact that I'm not using root in production, which would be really bad. I call composer install once again so I can do the cache clear and install assets and everything else that is happened to the installation, and do the warm-up. This is a nice part with Docker in production. You don't have to worry about, okay, I'm deploying, but before switching the traffic, I have to warm up Symfony cache and check the cache from Redis and stuff like that. You don't have to do that because you have a build stage thanks to Docker, and you can do that there. So when the container spins up on the cluster, it's ready. You can serve traffic nearly immediately. You just have to wait for the process to start up. Okay, going back to the CI. For the deploy, as I've been showing you on the GitLab interface, okay, I have another template here to split the pieces, but the point is Helm init, dash dash upgrade. So if I'm upgrading my version of Helm, it will be it will be done automatically. Wait, so the CI job will wait for the completion of the initialization, and which namespace I'm using. I've activated the Kubernetes integration in GitLab, so I will have environment variables with the namespace and stuff like that, and will talk automatically to the cluster. It's kind of easy. The documentation of GitLab is pretty comprehensive. It has even the commands to use on GitLab, on kubectl, to extract the right values from your cluster automatically. It's really easy. Helm upgrade dash dash install. Okay, this is basically the core of your deploy. You're saying, okay, I want to upgrade my application, but if it's not there, install it. Dash dash atomic, it's another really, really, really nice feature. It means that if something fails, the rollback is automatic. Really, really nice. Because if you do some mistake, if your container will not spin up because, I don't know, not enough memory, or you've written the wrong script, you've mangled somehow the front controller, I don't know. If something goes wrong and your pod doesn't spin up correctly, Helm will just roll back. In reality, the normal situation is you don't have enough resources, so you have to spin up new workers, and it will hang in there waiting for the resources. Now you have just two other pieces, namespace and tiller namespace. Okay, what's the namespace to deploy and where is tiller located? And then you have dash dash set. With dash dash set, basically you override the values that you have in values YAML. So you can pass everything else which is not fixed. So for example, you can give the up tag, which is the value that I use to say, okay, this is the comic that I'm deploying. I'm using it as the tag of my image, so use that. So if you go look to my charts, you will see that in the deployment, you see here that I have two parameters, one for the name of the image and one for up tag. So just changing that means that you're deploying your application. Okay, I know that I'm nearly out of time, and I didn't reach the part where I show you the feature branch, right? But in the reality, it's already in there. Just by the fact that I'm using Helm parametrized, and then I'm using the CI and passing through the parameters, that means that I can spin up as many environments as I want. Because I just have to change a few things, and I'm done. In my deployment, basically, I have to change the commit, if I have to, a URL to say, okay, this is production, this is staging, this is something else. And if I need, well, the environment slug, so I can write the prod, staging, review, whatever I want. Okay. So, first example. My application is currently deployed here. Okay, it's pretty simple. You can say that. But if I want to spin up something new, so let's say feature one. Okay, I have a really simple controller in here. So let's say typo. Give me a random number. Okay. So I'm not tricking you. It's not. This is not rehearsed. Okay. Live demo. Push. Okay, it's going. So I can go back to my pipelines, and I can see it's running. So just because it's not developed, it's not master, I have this pipeline. Well, it's kind of the same. It's just a stop at the end in addition, and it's running. Okay, since this will take some time, I think that if you want to ask some question in the meantime, you can do that. No one? You're just waiting for the demo? Let's try. Okay, so I can try to describe what's happening in here. Okay, basically, I have the CI that is starting We'll start with a container of my own that has Docker Compose. It will try to, okay, it will clone the project for me. No submodules, luckily. It's a spawn of the devil. Login. Docker Compose pull. Okay, I don't have anything to pull, so it will be a bit slower because I don't have the cache, but it's running. You probably recognize this, and this, and this. It's kind of familiar, okay? So basically the same stuff that you had to push and to do with Symfony and stuff like that, your deployment script. Now, cache warm up. Oh, already finished. Pushing the image. Job succeed. Okay, kind of fast. So let's go back to, sorry, I don't see the tabs. It's already going to deployment. Okay, maybe in here, instead of seeing this, it's a lot more nice to do watch. -1 kubectl get pods. Okay, it's live. In a few seconds, we'll start to spin up the containers. So yeah, container creating. We have 2 replicas. One is already running, and now this is the other one. Kind of fast, okay? Yeah, it's a simple application. It's fast because of that, but still, all automatic. I've added at the end, no, it's failed. Why? Ah, right. Nasty bug with Helm. The first deploy always fails because it mismatches something with the fact that it doesn't have anything from the previous deploy. So probably I just need to run it again. It's already running, so it will say, okay, it's already in there, so everything is okay. The only, okay, I can show you that on GitLab you have an environment page where you can see everything that is spin up. So I have prod staging, and as soon as the deployment is successful for GitLab, it will show you review, feature 1 down here. This warning is just an annoying one. I've seen it just this morning on the train. Basically, it wants to add a label, a custom label on top of the deployments to match what I'm seeing here to what it's inside the container. Okay, this is the new environment. I can open it, and that's all. The URL is partially generated automatically. Basically, I use the name of the branch, and then GitLab appends some random pieces to avoid overlaps in some cases. And that's all. So imagine being able to do something like this while you're developing, sorry. You're building a feature, you're missing some pieces, you want to ask some questions to some product people, you want to be sure that you're building the right stuff in the right way. You can just code something, maybe outcode some passages and show it to them. And this is really, really powerful because this kind of stuff can be used manually, can be used automatically to run, for example, end-to-end tests. You can use them to give them to your QA people or stuff like that. Or even if you're a small shop and you want to show them to your clients, this is perfect. You don't have to mangle their production environment. You don't have to merge your work. You can leave it as a work in progress and show it to them, and that's all. Then, when you're finished, if you don't want to waste too much resources, you go to the stop job. No, maybe I cannot trigger it from here. I need to do that from the exterior world. Okay. Stop review. We'll run the last job, which is basically Helm stop or Helm delete. I don't remember. I think it's in here somewhere. Let's see, review. On Helm delete, it's a bit more harsh. And the release will be deleted. And if I go here, this will disappear in a few seconds, probably. I hope. Nope. Terminating. Okay. Gone. So this is really ephemeral. You don't have to waste resources, as many as you need. you can just click a button and it's there. The really nice thing is that you can give this button to anyone. Since it's in the pipeline, you just play. You can even make the deployment manual. You can say, okay, in each branch I just built, then if you click play, it will be deployed. If I click stop, it will shut down. So you can give them to someone which is not you, which is not a developer. Say, if you click here, it will start up. At the end, it will show you the URL that you need to reach to see the new environment. And when you're done, you just stop it so we don't waste resources. And that's all. Thank you.